Good morning to one and all. In this video, I'll be presenting our project Brain Disease Recognition using EEG signals. The project is basically done by four of us, Abhijit, Achyuta, and Adarsh and Chaitanya. And we have done this project under the guidance of Dr. Veena ma'am, who's an assistant professor of ISC department. So before we start explaining about my project, there is a brief introduction about the project. So the basic idea over here is that's nothing but the basic disease which we are predicting, the brain disease which we are predicting over here is epilepsy, which is also called as epileptic seizure. So this epileptic seizure basically occurs due to the neurons in our brain. We all know that brain basically consisting of large number of neurons, and each neuron is basically responsible for sending messages to various body parts. So when I'm performing any particular activity, let's say if I'm raising my hand, that's one of the activity which I'm performing. But that neuron has to send to my hand a message to raise. Like that, whatever activity, when I'm performing some activity, the brain's neurons basically sends a message. What if my brain's neuron sends a wrong message? Or let's say it sends unwanted message. Then that type of condition is called as an epileptic seizure. This is a condition which is commonly observed in a people who are doing abnormal things. Abnormal things in the sense, suddenly their hand rises with for no reason. This is one of the condition. Okay, so here what happens is basically epileptic seizure is basically predicted using EEG signals. EEG signals are nothing but electroencephalographic signals. So we have considered the EEG signals as an input to predict this particular disease. Before we start about the prediction, we need to know what exactly is EEG signals. So in EEG signals, we have different types of EEG waves. So when I'm performing any activity, let's say if I am basically sitting or if I'm closing my eyes, then one form of the wave is basically generated in the brain. So for every activity that I perform, there is one form of the brain, one form of the wave that is basically being generated in the brain. For example, here you can see that if there is something, if I'm drowsy, then the theta wave is generated. That modulation of the wave is basically generated in the brain. So you can also observe in the figure that gamma waves are basically having high frequency and they're like 20 hertz, 20 hertz, and they're like around 10 to 20 waves per second. Whereas if you can observe, delta waves are very less, like there are only some 3 or 4 waves which are occurring per second. So in terms of epilepsy, when we did a lot of research in terms of epileptic seizure point of view, we also found out that epileptic seizure condition is mostly observed in theta, delta, beta waves. This is the type of waves where the epileptic condition is observed. However, it might occur in other forms of waves also, but majority of the cases is occurring in beta, theta, and delta waves. Okay, this was the previous research what we did before we moved on to our machine learning predictions. So the problem statement was to basically to predict an epileptic seizures using ML-based algorithms. Whatever the existing algorithm is there, we want to provide a best model that would basically predict epileptic seizure condition. So initially, since it was a machine learning based approach, we need to do a lot of research in terms of societal relevance point of view. So when we talk about societal relevance point of view, since the disease is directly related to brain, there might be a lot of harms that might cause in a person. So that harms can be prevented. And also, yes, it is very much helpful to detect this problem. And in terms of medical point of view also, it is very helpful. And there is one point over here that has to be observed, that it also reduces the risk of suicide. Reduces the risk of suicide in the sense, for example, since my neurons control my entire body, what if my neuron provides me a message to kill myself? That might also happen, and it is also evident in many cases where people have killed themselves unknowingly in the sense they just did not want to kill themselves, but they have killed themselves because of unwanted messages that are being sent by the neurons. Yes, it is one of the dangerous disease. So since this is in terms of societal relevance point of view, since it's a machine learning approach, first we started our approach with EDA, which is nothing but exploratory data analysis. So we just plotted different types of graphs with whatever the frequencies which we got from our data set, which is taken from American Society. So when we plotted the different types of graphs, it was also observed that the conditions which are epileptic, the waves which are, for the people who are having epileptic condition, the waves that are generated are smooth, as you can see in the figure. Whereas in non-epileptic condition, the waves which are generated are rough. And also you can see the frequency of the waves. The frequency in epileptic seizure condition is pretty less compared to non-epileptic condition. So this was the analysis we found out through our exploratory data analysis, that is EDA. After that, we went on modeling our data. So when we model with already existing approaches, logistic regression or SVC or decision tree classifier, whatever it is, all those when we models, when we modeled our data set, we found out this accuracies. So it was observed that logistic regression gave us the worst accuracy, whereas random forest gave us the best accuracy among the existing models. So since a random forest classifier is an approach of an ensemble technique, so we thought why not develop an hybrid approach which is similar to a random forest with ensemble technique and other techniques. So that's where we started developing another approach, which is hybrid approaches. So first we developed a hybrid methodology, like hybrid approach. This is our hybrid methodology one. So here what we did was basically we considered two algorithms, which is considered to be subclassifiers. Here it was considered SVC and KNN algorithm were considered as subclassifier, and we trained them individually and we predicted output individually from those two models. And after that, whatever the output we got from SVC and KNN was given as an input to a meta classifier, that is random forest classifier. And the final prediction was made through random forest classifier. This was the approach for our hybrid algorithm one. So fortunately, it gave us a very good accuracy. It gave us accuracy around 92.210, which is better than SVC, which is better than KNN, logistic regression, and also the decision tree algorithm. And it is not better than random forest algorithm. So even if you observe the confusion matrix also, only 142 cases which it had to be where it predicted wrong, and again 288 cases were predicted wrong. Other than that, everything went fine. So then we went with another approach, which was basically developed with using ensemble voting technique. So in this ensemble voting technique approach, what we did was we took three algorithms, that is random forest, SVC, KNN algorithm, and we predicted them, trained them individually and predicted them individually. For example, let's say random forest predicts my output as 1 and SVC predicts as 1, KNN predicts as 0. So whatever the output which comes as a majority is taken as a final prediction. So the final, since two of my algorithm is giving me the same output and one is giving me a wrong output, then the final output is basically done with the majority. So under this case, when we trained our model with hybrid methodology 2, and we got a very decent accuracy around 95 point something, which was approximately equal to random forest classifier algorithm. And you can see only under 89 cases where it predicted wrong, and again 179 cases where it predicted wrong, and it is far better than all the existing algorithms and comparatively equal to random forest algorithm. And this was this was basically the final approach, along with so the hybrid approach we had applied for our model to model the model to predict the epileptic seizure. Thank you.